programming by example is an important subproblem of programming synthesis. It takes a set of input-output examples as input and generates a correct program corresponding to all given examples. Despite many existing applications of program by example, scalability remains one of the main challenges to apply its techniques. To optimize the performance of programming by example, many approaches have been proposed. Dynamic programming, represented by PROS framework, and structural probability, represented by euphony, are two important techniques among them. For a dynamic programming-based synthesizer, it first tries to divide a synthesis problem into subproblems. For example, the problem of synthesizing an expression returning AA can be divided into two subproblems of returning A, such that concatenating resulting programs of these two problems gives a solution to the original problem. Besides, the synthesizer also reuses results when visiting the same subproblems multiple times. In this example, the result of the first subproblem can be reused for the second one since they have the same requirement. The key idea of structural probability is that whether a program is probable can be predicted from its structure. For example, it is improbable for a decreasing operator to occur directly after an increasing operator. Therefore, structural probability can be used to turn off such states. All improbable programs can be skipped. In this paper, we propose a novel framework named MaxFlush. MaxFlush combines dynamic programming and structural probability for further speeding up programming by example. Two major challenges emerge while combining these two approaches. The first one is that dynamic programming is local but the structural probability is global. For example, expression increasing x itself is probable but becomes improbable in decreasing after increasing x. Therefore, it is unknown whether program fragment increasing x is probable or not. To overcome this challenge, we expand the definition of subproblems and utilize several search algorithms. The second challenge is that after expanding the definition of subproblems, the original reuse mechanism in dynamic programming becomes ineffective. Therefore, we design several reuse mechanisms to let MaxFlush reuse results among different subproblems. Our evaluation is conducted on a dataset containing 244 synthesis tasks for string manipulation and matrix transformation. We compare MaxFlush with 6 state-of-the-art synthesizers, and the results show that MaxFlush achieves significant speedups against them.